In this video, we're going to be solving LeetCode challenge number 17, which is called as letter combinations of phone numbers. If you're new to my channel, then welcome. And if you have previously watched my content, then welcome back. I am Radhika. This is my YouTube channel Datasad. Let's dive into our problem. So the problem states that given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like the telephone buttons, is given below. Note that 1 does not map to any of these letters. So if you look here, our 2 contains 3 digits, contains 3 characters A, B and C, and 3 contains 3 characters D, E and F. I'm just taking this example. So if we are given digit 23 and we need to find all the possible combinations using 23, what we first need to do is, first combination would be AD, then AE and then AF. So I'll write AD, AE, AF. Then we will start with B. So I'll remove all of these, and then the next combinations would be BD, BE and BF. So BD, BE and BF. And lastly with the third character, which is C, so CD, CE and CF. CD, CE and CF. We can't make any other combinations, so this is how it will look like. If we are given an empty string, then we just want to return an empty list. And if we are just given one character, say 2, then we just want to return A, B and C, only just those characters, because there is no other character to loop through. This is exactly what the challenge is about. So if you think carefully, what we are doing is, if we are given number 23, so first we have 2. What we are doing from 2 is, we are grabbing what are the characters that are related to 2. So the characters that are related to 2 are 3 characters, A, B and C. Then we are taking the second digit, which is 3. So from 3 we have 3 more characters. So from A we can have D, E, F. Then from B we can have D, E, F. And then C we can have D, E, F. So first we find out the characters which are related to the first digit, then we find out characters which are related to the second digit, and then we start backtracking. So we go D and A and E, F and A, D and B, E and B, F and B, D and C, E and C, F and C. So what we are essentially doing is backtracking. We are first forming the tree and then we are backtracking it. So this is the same logic that I'm going to use in the code. First thing that we need to think about is, how do we know 2 maps to ABC, 3 maps to DEF? How do we store this? And if you know the data structures in Python, we can use a dictionary for this. So I'm going to create a dictionary which would say 2 and it maps to AC, then 3 it maps to DEF, and I'm going to create this full dictionary. So this is how we are going to store which digit maps to what characters. The second thing that we need to find out is, what should be the stopping condition? When do we know that DA and we don't have to go beyond A? There's nothing beyond A. How do we make the algorithm understand this? So to do this, if you look carefully here, all these combinations AD, EA, FA, DB, EB, all of these, they are of the same length as our digit that we are given. So if we have, let's say 2, 3, 4. So the first combination, so 2 is with ABC, 3 has DEF, 4 has GHI. So first combination with 2 could be ADG, then the other combination could be ADH, the other one could be ADI, like these. So the length of these combinations is same as the length of digits that we are given. If we just had 2, we just had A, B and C as our final result. So again, the length of our string is equal to the length of our digit. Digit is of length 1. these will also be of length 1. So this is the same logic that I'm going to use. When length of our current string becomes length of our digits, which means we have got all the combinations from that branch, and we can stop visiting that branch and move to the other branch. There is a very simple backtracking logic. Let's start writing our code. First, I'm going to define the final list that we are going to return, and I'm calling it final. And because this is a list, so I'm initializing it as a list. Then we need to define our digits dictionary. So I'll say digits dictionary, and I'm just going to map it. So 2 is mapped to ABC, 3 is mapped to DEF, 4 is mapped to GHI, 5 is mapped to JKL, 6 is mapped to MNO, 7 is mapped to PQRS, 8 is mapped to TUB, and 9 is mapped to WXYZ. So this is our mapping. We had to hard code it because there is no other way to define how 2 is mapped to ABC, 3 is mapped to DEF. So that's how we have defined it here. I'm going to start my backtracking function. I'm going to define that function just inside this. So DEF backtrack digits, because we are backtracking digits. So first I'm defining the current index that I am at. So I'm calling it current index, and then what is the current string in hand? So current string. With current index, I mean, suppose we are given digits which is equal to 23. Current index would mean, are we at index 0? Are we at index 1? Where are we in this current digit? And the current string would mean, are we at A or we are at AD? Are we at B or we are at BD? What do we currently have as the string? So that's what this current string will hold. So let's start defining the function. We know that the stopping condition is when the length of this current string becomes length of our digits. So let's write that. If length of our current string is equal to length of our digits, then we know we have to add it. So in final, I'm going to append the current string, because now we have full AD if we are evaluating 23, let's say. And then we're just going to return. And if this is not true, then for every character in, how do we get ABC? We have digits underscore dict as our dictionary. And if we have to go for this index, what we need to do is digits of this current index. So that's what I'm writing over here. So this is our dictionary, digits underscore dictionary. To fetch the index, that would be index of digits at the current index that we are evaluating. Suppose our digits is equal to 23. Let us say we are at index 1 right now. So with index 1, what will be digits of 1? This is our current index. Digits of 1 would be equal to 3. So this answer would be 3. And in here we are doing digits underscore dict of 3, because that's how it got evaluated as. So digits of 3 would be equal to DEF. So this is how we are getting what these digits map to. So we are getting DEF, and then in DEF we are evaluating D, E and F separately. So for character in string. So for each character, we are again going to call our backtrack digits method, and I'm going to call it on the next index. So current index plus 1, and then I'm going to call it with what would be our current string. Current string would be the character that we are evaluating. So with this as character, I'm again going to call the next one. Now we need to call this. So I'm saying if digits, if we have something in digits, then we call backtrack digits, and the first index will obviously start at 0, and then we'll start at as empty string. and then I'm just going to return final. So if we don't have digits, like if it's an empty string, then we're just going to return an empty list, and that's what the challenge asked us to do. So now let's run this using an example by hand. To explain your code, let us take an example of digits equal to 2, 3. Now first we will define our final, that will be equal to an empty, and now we'll enter if digits. Yes, we have digits, so we'll do backtrack, and backtrack would be 0, the first index that we are starting, and an empty string. So this is my current index and this is my current string. Now when we do this, we are entering this. So what's happening here? We are first checking if our length of current string is equal to length of digits. Length of current string is 0. Length of digits is 2. This is not equal, so we are not going to enter this. We are directly going to go into this for loop. So in here, this is where we are right now, and inside it we are going for. Let's try to evaluate this part first. So our current index is equal to 0. That's what we have here. What will be digits of current index? That will be equal to digits of 0. What is digits of 0? Would be this 2. Now we have digits underscore dictionary of this digits 0, which means of 2, which is equal to A, B, C. And this is how we get our characters. So first we will do for A, because that's the first character. What we are doing? We are again calling backtrack. So backtrack. What is our current index? Current index is 0, because this is what we are evaluating right now. So 0 plus 1 is equal to 1, and current string plus character. Current string is empty string plus character that we are evaluating is A. So now our current string becomes A. So now we are evaluating this backtrack. So I'm again at the start over here. Now again I'm going to check if length of current string is equal to length of digits. Is it true? Length of current string is 1. Length of digits is 2. These are not equal, which means we are again entering our for loop. So this is an inner loop to this. So for, now again we evaluate what is our current index. So instead of 0, our current index now becomes 1. Digits of current index, which means digits of 1. If you look here, digits of 1 would be equal to 3. So instead of 2, we have 3. So digits underscore dictionary of 3 would be equal to, instead of this, we have D, E, F. So that's how we have for D, first character in the string that we have for the loop. So for D, now again, we are evaluating backtrack. Now what we are doing? Current index. Current index is this. We are not going to take this because we are evaluating this first. So current index plus 1, which is equal to 2, and current string is this for us. So current string A plus the character D. So our current string becomes AD. Now we are doing this backtrack. We are calling backtrack multiple times here because we are diving deep into each layer. So now we have backtrack to AD. So again, we go here. If length of current string is equal to length of digits, length of current string is 2. Length of current digits is also 2. Yes, that is true, which means we are going to append our current string. So now here our final would be equal to AD. And we don't have any backtrack, we just return it from here. So now we enter the second character of the loop. We entered E because we are just returning over here. Now we do backtrack. What is our current index? Current index is still 1. We have not updated any index over here. So current index is still 1. 1 plus 1 is 2. And what is our current string? A. And we are going to have current string plus character. So current string A plus E, which is equal to AE. So we are calling backtrack to AE. When we do that, again we check if length of current string is equal to length of digits. Length of current string is 2. Length of digits is also 2. It is true, which means we have to append to our final. So now our final would become AD then AE. Then it's a return. So we are again coming back to our loop. F. So again we do backtrack. What is our current index? It is 1. 1 plus 1 is equal to 2. I'm just evaluating this part. And then what is our current string A? We have to do current string plus character. So current string A plus our character F. So AF. What is backtrack to AF? So again, we call this function. First, we have to check if length of current string is equal to length of digits. Length of current string is 2. Length of digits is also 2. So in this case, we again have to append. So our final would be AD, AE, AF. So this got evaluated, this got evaluated, this got evaluated. Even this got evaluated. Backtrack 1A got evaluated. Now we enter for loop for the second character B. So again we do for B. Here we have to do backtrack. What is our current index? Current index is 0 because we were in this loop. So 0 plus 1 is equal to 1, and then current string plus character. Current string was empty string and character now would be B. So B. We call backtrack 1B. Now here again, when we do, if we first check if length of current string is equal to length of digits. Is it true? Length of current string is 1. Length of digits is 2. It's not true, which means we enter for loop. For character, and then the index that we are at right now is 1. So at 1, our answer is DEF. So we do for D. We have to do backtrack. What is our current index? It is 1. So 1 plus 1 is 2. What is our current string? It is B. And we have to add our character. So BD. So we do backtrack BD. When we do backtrack BD, we first check if length of current string is equal to length of digits. Length of current string is BD, 2. Length of digits is 2. This is equal, which means we have to append. So our final would become here AD, AE, AF, and now we add BD. Now again, I will just write the rest of the part over here. I have returned over the for loop. So the next thing in for loop is E. So now we do backtrack. What is our current index? We are here. We have already solved this one. We are here. So 1 plus 1 is 2 and our current string is B. The current character that we have is E. So this will be BE. So we do backtrack B to BE. So here again, length of current string is equal to length of digits. Yes, that's true. Length of current string is 2. Length of digits is 2. So in this case, we have to append. So our final would be AD, AE, AF, BD, BE. These are all strings. We again come back to our loop. So for F, again we have to do backtrack. What is our current index? 1. We have already evaluated this. So we are back again here. 1 plus 1 is equal to 2. Current string is B and the new character is F. So BF, we have to evaluate this. When we try to again call the function, first we check if length of current string, which is 2, is equal to length of digits 2. Yes, it is true, which means we have to append. So now our final would be equal to AD, AE, AF, BD, BE, BF, because now we have added this. Now we have evaluated all of these. This is done, and backtrack 1B is also done. Now we do the same thing for C. So I'm just going to move things over here. So now we have for C, we are going to call backtrack. Our original backtrack is this one where we evaluated A and B already. Now is C's turn. So backtrack, our current index was 0. So now it will be equal to 1 because we have to do current index plus 1. Current string was an empty string. So empty string plus the character C will be equal to C. When we do backtrack 1C, then we again check if length of current string, which is C, is equal to length of digits. Length of current string is 1. Length of digits is 2. It's not true, which means we can't go in these we have to enter the for loop. So we enter for loop for D, because that's what this is going to evaluate to, DEF, and we take the first character for the first loop. So again we do backtrack. What is our current index now? 1. 1 plus 1, 2, and then current string is C, and we add D to it. So CD. With backtrack to CD, let's again evaluate. If length of current string CD is true, length of digits is also true. It is true. So we need to update our final. So this will be equal to AD, AE, AF, BD, BE, BF, and now we add CD. Then we have evaluated this. We again have to go back to our for loop. So for E, we do backtrack. Now what is our current index? 1. We are here in the for loop. So 1 plus 1 is 2. And what is our current string? C. And the next string that we have is E, the character that we need to evaluate, E. So we do backtrack to CE. Again, we'll check if length of string is equal to length of digits. Yes, it is true. Length of string is true. Length of digits is also true. In this case, we just do final AD, AE, AF, BD, BE, BF, CD, and CE. Now again, we go back to our loop, which is for F. And again, we do backtrack. Backtrack for, this is our current index, 1. So 1 plus 1 is 2. Current string is C. C plus our current character, F. So backtrack to CF. Again, if length of current string is equal to length of digits, yes, that is true. So we just have to have our final, which is equal to AD, AE, AF, BD, BE, BF, CD, CE, CF. And now we have completed the for loop as well. And the final answer that we return is this. So this is how the full code is working. If you have any questions, then please put them down in the comments below. Thank you for watching. I'll see you in my next one.